A very good morning to all of you. This is second video from the unit Arithmetic Progression. In the first, I was discussing about the sequence. Here in this, consider the following list of numbers. In first, each term is 1 more than the term preceding it. In second, each term is 30 less than the term preceding it. In third, each term is obtained by adding 1 to the term preceding it. In fourth, all the terms in the list are 3, that is, each term is obtained by adding or subtracting 0 to the term preceding it. In fifth, each term is obtained by adding minus 0.5 to it or subtracting 0.5 from it, that is the term preceding it. Let us consider some more examples. In A, we have the heights in centimeter of some student of a school standing in a queue in the morning assembly, and this is 147, 148, 149, 157. It is till 157. In B, we have the minimum temperature in degree Celsius recorded for a week in the month of January in a city arranged in ascending order, and this is minus 3.1, next is minus 3.0, minus 2.9, minus 2.8, minus 2.7, minus 2.6 till minus 2.5. In C, we have the balance money in rupees after paying 5% of the total loan of rupees 1000 every month, and it is 950, next is 900, the next term is 850, and next to it is 800, and so on, last term is 50. In D, we have the cash prizes in rupees given by a school to the toppers of classes 1 to 12, and this is respectively 200, 250, 300, 350, and so on in the same way, and the last term is 750. Here in all the list, we see that successive terms are obtained by adding or subtracting a fixed number to the preceding terms. Such list of number is said to form an arithmetic progression. In short, it is called as AP. So now it's time to define AP. Here is the definition. A sequence in which each term differs from its preceding term by a constant is called an arithmetic progression, written as AP. This constant is called the common difference of the AP. In other words, we can say an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed term is called the common difference of the AP. Remember here that this common difference can be positive, negative, or 0. Now you can see here that A plus D, A plus 2D, A plus 3D, and so on represents an arithmetic progression where A is the first term and D the common difference. This is called the general form of an AP. So, general form of an AP is given in the same sequence. Now I would request you to see these examples again. Note that in examples A to D here, there are only a finite number of terms. Such an arithmetic progression is called a finite arithmetic progression. Also note that each of these arithmetic progression has a last term. Now again consider the following list of number, and here the arithmetic progression in examples 1 to 5 in this section are not finite, so they are called infinite arithmetic progressions. Such arithmetic progression do not have a last term. It follows from the above discussion that the sequence A1, A2, A3 and so on, AN, and next to AN is AN plus 1 and so on, is an AP with common difference D. If and only if we find the difference between Tn plus 1th term and nth term, that is an plus 1 minus an is equal to D, for n is equal to 1, 2, 3, 4 and so on. This suggests us the following algorithm to determine whether a sequence is an AP or not. When we are given an algebraic formula for the general term of the sequence. So here we have the algorithm, that is how to solve the problem. In step 1, first of all we will have to obtain the nth term, that is an. Step 2, replace n by n plus 1 in general term an to get an plus 1th term. Step 3, calculate the difference, that is an plus 1 minus nth term, that is an. Step 4, check the value of the difference. If the difference is independent of n, then given sequence is an arithmetic progression. Otherwise, it is not an arithmetic progression. Let us try to understand this considering one example. And here is the example. So that the sequence defined by an is equal to 4n plus 5 is an arithmetic progression, also find its common difference. So here we have the general term as 4n plus 5. Replacing n by n plus 1, following that algorithm which I have discussed now, we get an plus 1th term is equal to 4 in bracket n plus 1 plus 5, which after simplification get 4n plus 9. Now we will find the difference between Tn plus 1th term and nth term, that is an plus 1 minus an, which gives 4n plus 9 minus 4n plus 5, that is equal to 4. So clearly the difference between Tn plus 1th term and nth term is independent of n and is equal to 4. So the given sequence is an AP with common difference 4. Let us consider one more example. And here in this, so that the sequence defined by an is equal to 2n square plus 1 is not an AP. So here we are supposed to prove that if general term is 2n square plus 1, then it will not give us an AP. We have an is equal to 2n square plus 1. So following that algorithm, replacing n by n plus 1, In an we obtain a n plus 1th term is equal to 2 in bracket n plus 1 whole square plus 1, which after simplification it is equal to 2n square plus 4n plus 3. Now finding the difference between t n plus 1th term and tn term. So we have a n plus 1 minus a n is equal to 2n square plus 4n plus 3 minus 2n square plus 1, which gives 4n plus 2. So clearly the difference between t n plus 1th term and tn term is not independent of n and is therefore not constant. So the given sequence is not an AP. Thank you for today.